Hello students, in last lecture we learned about what is memory hierarchy and we discussed what are the different levels of memory hierarchy. We studied about what is register, what is cache, what is main memory, what is magnetic disk, what is magnetic tapes, and the last topic which we discussed in last lecture was regarding a ROM chip. So today we'll continue with the ROM chip and we'll see in detail different kinds of memory available and how they work. Now the diagram you can see in the slide is related to ROM chip. Now as compared to RAM chip, you can see here there is no option for read and write as compared to RAM chip, but we already know that ROM can be only read. As the ROM chip can only be read, so we only have a data bus that can be used for the output and not for the both purpose output and input. In RAM chip we saw that the data bus which was being used was bidirectional. Now we saw what is ROM chip and we saw the construction, but for ROM chip to work, now to read something, two conditions here is necessary, that is CS1 should be 1 and CS2 should be 0 in order to this unit to operate. Otherwise the data bus will be in high impedance all the time. And we also observed that we don't have two options here, read and write, as the ROM chip only can be read. Only the two thing is important here, that is CS1 and CS2 and its values. Moving to next slide, let us discuss what is auxiliary memory. Now in last lecture also we discussed about auxiliary memory and I gave you different example of auxiliary memory. Today we'll see in bit detail what is auxiliary memory and its types. Now two basic types that we have already discussed is hard disk and magnetic tapes. Hard disk can also be told as magnetic disk, and the magnetic tapes are nothing but the cassettes or films that cassettes are nowadays not used, but films are still being used. Now moving through first point, magnetic disks and tapes are most common auxiliary memory devices. The important characteristic of any device are its access mode, access time, transfer rate, capacity and cost. When I was discussing memory hierarchy, at that time I told you that the faster the memory, expensive it is. That means the memory which is more faster, it tends to be more expensive. Now related to any disk, if we discuss the average time required to reach a storage location in memory and obtain its content is known as access time. Access time is nothing but if we are trying to access a data or read a data. Now while we want to access something, the access time also consists of seek time. The seek time is nothing but a time required to position the read-write head to a location. Now we'll discuss what is read-write head in next slide. And the transfer time is nothing but a time that is required to transfer the data to and from the device. And transfer rate is the number of character or word that device can transfer per second. Now if I take an example of a hard disk, when I want to read something, when I want to read a data, I can call it as a access time. Now in hard disk we have a read-write head. The read-write head, the time it takes, that is known as seek time. When I want to transfer something, when the data is already located but the data has to be sent somewhere, that has to be a transfer time, and the speed at which the data is getting transferred is nothing but a transfer rate. Now in this diagram you can see that we have a disk. A square symbol shown here is nothing but a read-write head. Now you can see three circles here. These circles are tracks, and the area which is inside a particular circle is known as sector. Now this track, sector, read-write head will be more clear in next slide. Look at this slide. Now cluster, track, cylinder, and again a sector. Sector is a portion of a particular track. If I combine more than one sector, it becomes the cluster. If I combine many cluster, it becomes one track. And when all the disks are combined, it forms a cylinder. When we use a read-write head on the disk, it can be used to locate a data, to read from the hard disk. Just to understand the working in a better way or in a practical way, search on a Google for a gramophone and its record. You'll come to know that what is actually the meaning of read-write head. Mostly read-write head is for accessing the data. Now going through this point, a circular plate constructed of metal or plastic coated with magnetized material. Now material is magnetized. When it is magnetized, it is able to write something. We are able to write something, some data on it. Now both the side of disk are used and several disks may be stacked on one spindle with read-write head available on each surface. Now going through the diagram again, if I put something in between the cylinder, now it is nothing but a spindle. Now read-write head will be the part to read something. Now bits are stored in a magnetic surface. As I told you that when it is magnetized, we can use to store something. The tracks are commonly divided into sections that are called as sectors. Now tracks is further divided into sector. In most systems, the minimum quantity of information which can be transferred is a sector. Now related to this, you must be knowing that if the hard disk, whether it is internal or external, when it is used very frequently, what happens? Bad sectors are created, and most of the time your operating system may behave in a weird way. It may hang, it may get freezed, and errors may arise. So this kind of errors can be due to the bad sector in the hard disk also. Now moving to next slide. Now some unit use single read-write head, or some may have separate read-write head provided for each track, but it is more expensive and is found only in very large computer. The track address bits are used by mechanical assembly, electronically or mechanically, to move the head into specified track position before the reading writing. A disk system is addressed by bits that specify the disk number, the disk surface, the sector number, and the track within the sector. That means every disk will be addressed by its number, its surface, and a sector number on the track. Now in starting I told you that magnetic disk and magnetic tapes are two kind of auxiliary memory. Now in magnetic disk also we have parts. You might be familiar, but you might not have seen, because floppy disks are not much used nowadays. Floppy disk are also a kind of magnetic disk which is not permanently attached. The first point says that disks that are permanently attached to a unit assembly and cannot be removed by user can be called as a hard disk, but a disk drive that can be removed can be known as a floppy disk. The disk used with a floppy disk drive are some small removable disk made of plastic, and it is coated with magnetic recording material. Now, magnetic recording material which we are talking about is nothing but the material which is being used in cassettes. The same plastic, then same material will be used inside the floppy disk. We'll see the diagram which kind of material it is and what it looks like. Now in this diagram you can see the first portion which is showing the black film. It is a open floppy drive, a plastic film coated with a magnetic material. Magnetic material will be used to store data. As it is coated, we can store data on it, and you can see there are three different types of floppies. This floppy drive came with a very limited space of 4 MB to 5 MB, not more than that. And the only problem with this floppy drives was they were getting corrupted very easily due to the dust particles. Now let's see what do you mean by magnetic tape. The tape itself is a strip of plastic coated with magnetic recording medium. See, everything we discussed till now, the one common thing that we have is magnetic. Now magnetic, again to remind you, a magnetic material will be used in order to store data on that material. Bits are recorded as magnetic spots and on the tape along with several tracks. Read-write head are mounted one in each track so that the data can be recorded and read as a sequence of character. Now just remember, if you guys have used cassettes, when we were playing that song, we can directly jump on to the particular song, or what we can do is forward, reverse and stop it. Now, every song had a starting and an ending time in it. The information was being recorded in blocks referred to as records. A tape unit is addressed by specifying the record number and the number of characters in the record. The record may be fixed or variable length. While reading magnetic tape, think of cassettes and remember that how we were using those cassettes, how we were locating a particular song. Every song was of a variable length, not necessarily they were of a fixed size. Then you can understand the magnetic tape in a better way. Now these are the example of magnetic tapes. You must have seen in old movies that this kind of tapes were used to record something or to play something. And this kind of tapes were used to store data before the hard disk came into picture. Now before starting a new topic, I would request all of you to bring your pen and paper first. The topic name is associative memory. It is very important topic and it is bit tough to understand without drawing or without writing something. Memory unit accessed by content is called an associative memory. It is also known as content addressable memory. Now first point says that a memory unit accessed by content. Now what does it mean? That means memory will be accessed by the content and not by the address. Now till now we were knowing that we are accessing everything by the address. Now this kind of memory is accessed by the content. That means we have the content, and if we give the content, the content will be searched in the memory, not from the address. In other words, the memory is accessed by on the basis of data content rather than by specifying address or location. When a word is written in an associative memory, it doesn't require any address. Address is not given. The memory itself is capable of finding an empty, unused location to store that particular word. Now we are familiar that whenever we want to store something, we have to provide the address. But in this type of memory, the address is not required. The associative memory itself will search something, will search a place which is empty or unused, and it will store that word into that place. This was about the writing. Now let's see how it is read. When a word is to be read from an associative memory, the content of the word or a part of that word is specified first. The memory locates all the words which is matching that specified content and marks them for reading. Now let's see the diagram. First you have to draw the diagram and I'll explain something. Meanwhile you are drawing the diagram, you can pause the video. Draw both the diagrams. On left hand side, what we have is a block diagram of associative memory, and on right hand side we have is associative memory of M word and cells per word. Right hand side is a actual diagram and that one is a block diagram. Draw both the diagrams. Now in this diagram we can see the content of the block diagram is first argument register, second one key register, third match register, and we have a rectangle box which is associative memory array. Now the size of all these registers, if we discuss, the size of argument register is n bit, key register is n bit, M register is n bit, but the associative memory what is shown in the rectangle box will be M words, and M words will be of n bit per word. Now as it is shown in the block diagram, we can provide the input, we can read and we can write the associative memory. Now what I just told about the size, you can see in the right hand side that associative memory of M word, n cells per word. Now see, here we have different registers on the top, below we have the key registers, and in the last hierarchy we have cells. Now cells of the associative memory where everything is stored, words are stored, and outside it we have the M register. M register is for the match register. Draw both the diagram. Now question arises how to search something from associative memory. How does it actually works? Now note down few points what I am dictating. This is not given in the video. AR is a argument register. In this register we'll have the data which we are going to search. The key register is a kind of filter. For example, I don't want to search the full data that is mentioned in the argument register, but I want to search the part of a particular data that is in the argument register. For example, let us consider the content of AR is 101, 4 times 1 00. Now I don't want to search the complete content of argument register. I want to search only the starting 3 digit in the associative memory. So now what I will do is I will keep the content of K as 111 and all zeros because it's a key register. Now why I am trying to set all ones in the starting and zeros in the end? It's a filter. Now I can filter the data which I want to search. Now you can see that in AR we have 101. If I want to search 101, I have to mark the corresponding bit of K register with ones, and the bits which I don't want to search has to be marked with zeros. Now when we do the AND operation of AR register and K register, the value what we get is 101. So basically we are trying to search 101 in associative memory. Now let's again see the diagram which will show how to how the implementation is done. Content of AR is already visible to you on the screen, and the content of K is also visible to you. We want to search 101 in the associative memory. Now word 1 is nothing but the first array of the associative memory. If the data is not available in first word, it goes to the next word. Now you can see the content of first word is 100 and we want to search 101. So first word is not a match. Now in second word the content is 101 and the other content is all zeros and in the end 1, but as we are searching the starting string, this word 2 will result into the match. Now we have already seen how does associative memory works. Now few of the points regarding that. Associative memory is more expensive than a random access memory because each cell must have storage capability as well as logic circuits for matching its content with an external argument. Basically the expensive point is because this kind of memory requires extra logic circuits. More implementation has to be done if you want to implement associative memory. For this reason, associative memories are used in application where the search time is very critical and must be very short. Now it is rarely encountered in mainstream computer design. Now the next topic is cache memory, but before discussing what is cache memory, let us discuss what is locality of reference. Locality of reference analysis of large number of typical programs has shown that the references to memory at any given interval at a time tends to be confined within a few localized area in memory. This phenomenon is known as property of locality of reference. આનો મતલબ એ થાય કે આપણે જ્યારે પણ પ્રોગ્રામ આપણે જ્યારે લખતા હોઈએ, ફોર એક્ઝામ્પલ આપણે ફંક્શન ને લૂપ્સ ઇન્ક્લુડ કર્યા હોય આપણા પ્રોગ્રામની અંદર, તો જો મલ્ટિપલ ટાઈમ્સ આપણે ફંક્શન યુઝ કર્યા હોય તો ઘડી ઘડી એ પર્ટિક્યુલર પાર્ટ, એ પ્રોગ્રામનો પાર્ટ રિફર થશે મેમરીની અંદર, બરાબર? એટલે પાછો એને જગ્યા ઉપર આપણો ફ્લો થશે. ફંક્શન બે વખત કોલ કર્યો હોય તો આપણો પ્રોગ્રામ મૂવ થશે ફંક્શનમાં 2 વખત. ફંક્શનની બોડી 2 વખત એક્ઝિક્યુટ થશે. દેટ મીન્સ વી આર ટ્રાઇંગ ટુ એક્સેસ ધ સેમ એરિયા ટ્વાઇસ, બરાબર? આને કહેવાય વી આર કન્ફાઇનિંગ ધ પ્રોગ્રામ ટુ અ ફ્યુ લોકલાઇઝ એરિયા ઇન ધ મેમરી. Now if the active portion of program and data are placed in the fast memory, the average memory access time can be reduced, thus reducing the total execution time of a program. Now what we are talking about is implementing the cache memory. ઘડી ઘડી આપણે પ્રોગ્રામનો કોઈ પર્ટિક્યુલર ડેટા એક્સેસ કરવો પડતો હોય તો એને આપણે એક નાની પણ ફાસ્ટ મેમરીમાં રાખી દઈએ તો જલ્દી એક્સેસ થઈ શકે ને આપણો પ્રોગ્રામ પણ રન થઈ શકે properly. The next topic of this chapter will be cache memory, but it will be in the next part. Now in the end of the video I am giving you the questions for assignment 3. Now you have to complete this assignment 3 before 10th April.